Assalamu alaikum. Greetings, all of you. My name is Anas Hassan, and I am doing internship as a data science and business analytics at the Sparks Foundation. The task one of my internship is to predict the percentage of students based on the number of study hours. What will be the predicted score if a student studies 9.25 hours a day? Now let's start input our packages which we'll need in this entire project. NumPy, Pandas, Matplotlib, sklearn, and some other additional packages. N- Now start import our data set into our variable xtrain, ytrain. Xtrain is the total hours student study and ytrain is the student's score. Load the data set. The data set are get from this link and we read CSV file by pandas and save the data into xtrain, xtest, ytrain, ytest, which is by splitting. As we as we see data imported successfully. This is the hours and this is the scores of the students. Total number of students is 25. Now let's start dataset visualizing. This is often useful to understand the data by visualize it and find the data trends in it. I use scatter plot to visualize the data. Plot.scatter and xtrain is the xtrain, ytrain is the parameters, and markers is equals to x means cross. C is equals to red. Title scores versus number of hours study. Y level scores and X level is number of hours study. As you can see, the data set is linearly distributed. So we have to choose a linear model in which the data set is perfectly fit in it. With this model, the input is number of hours and have the model estimate scores of the student. Supervised machine learning model using linear regression. I solve problem. I try to fit the linear regression model parameters W and B to dataset. The model function for linear regression, which is a function that maps X hours to Y scores, is represented as function W of and B of X is equals to W into X plus B. This is the linear model, linearly equation to best fit in our data. To find it, we use compute cost and gradient descent method. Gradient descent involves repeated steps to adjust the value of our parameters W and B to gradually get a smaller and smaller cost function. At each step of gradient descent, it will be helpful for you to monitor your progress by computing the cost function. To train a linear regression model, you want to find a best W and B parameters that fit your dataset. To compare how one choice of W and B is better or worse than the other choice, you can evaluate it with a cost function. J is a function of W and B. This value of the cost function depends on the value W and B. The choice of W and B that fits your data the best is one that has the smallest cost function J. To find the value W and B that get the smallest possible cost function, you can use a method called gradient descent, right? Gradient descent Gradient descent uses cost function. With each step of gradient descent, your parameters W and B come closer to the optimal values that will achieve the lowest cost function. And in this way, the linear line fits data perfectly. This is the cost function code. M is equals to number of training examples. And by this, iteratively, we find cost function. This is the cost function formula. We describe the cost function formula in it, and by this we got total cost. This is the compute gradient. We find gradient descent by this. uh, this also iteratively used to find the gradient function. This is the formula in it. This is the gradient descent helper function, in which the parameters are x, y, and w, some initial value which we specified. You can see in a later. B and cos function, gradient function, and alpha is equals to rate and number of iteration, how many times you iterate the model. This is the code below. We find w and b by gradient function. W and b updated repeatedly. We return w and b and some other stuff. Now let's run the above gradient descent algorithm above to learn the parameters of our dataset. We set initial w and b to 0. Iteration is 20. Number of iteration is equals to 20. And alpha, the rate, is equals to 0.01. As you can see, the iteration is 0. Cost is 771. After some iteration, the cost function gives a minimum. After it, the cost function is gradually decreases. After it, it converges. Cost function, we found W and B by gradient descent formula is 9.9 is W and 1.57 is B. Now let's start prediction. M is equal to training example predicted for I in range. This is the loop in which the prediction is saved into it. Now plot the predicted values to see the linear fit. This is the plot, and we use scatter plot also to visualize. As you can see, this is the our data, and this blue lines is linear model which best fits in it. This above is a linear regression model, right? Now prediction for 9.25 hours a day, which is the task of my internship. So number of hours is specified by 9.25 hours, and predict is equals to number of hours multiplied by w, and b is a parameters. Number of hours is equal to 9.25. Model predicted our score is 93.87. Now let's start by model accuracy. How much our model is accurate. We use sklearn as our library. So mean absolute error of this is 5.20, which is less, but it can be additional modified and improve it later. Thank you so much for your time. This is the task. I hope you enjoyed. Thanks.